Hey dude, what are you doing?
Oh, don't mind me. I'm just limbering up before our conducting polymers class.
Not like that, you're not.
What do you want about?
Your form is really sus. And if you keep extending your knees past your toes, you're gonna hurt yourself.
How am I supposed to know when that happens?
What if I told you that I can make a device that would tell you when your form is whack?
That sounds pretty complicated. Are you sure this isn't a scam?
Yeah, bro. I can make a super cool device using polyaniline. Come on, let's go. I'll show you. In order to make polyaniline, we utilized a two-phase synthesis. The first phase was a mixture of aniline monomer and toluene. The second phase consists of ammonium persulfate and hydrochloric acid. The two solutions were mixed together in one vial. A gradual change in color was seen as polyaniline nanofibers formed at the interface of the two solutions. The mixture was left to react for a total of a half hour. The result was a dark green solution.
To make the sensor, we first placed a long sponge strip in a centrifuge tube and filled it with the PANI solution. We let the sponge marinate in the polyaniline solution for about 24 hours to make sure it was fully saturated. We then dried the sponge using a hot plate and a blow dryer. We wrapped copper tape around each end of the sponge 3 times. We pressed the copper tape down firmly on the top and bottom surfaces to have good electrical contact. We twisted two 22-gauge black and red wires together and soldered one end of each wire to one of the copper tape. The other end of the wires were hooked to our sensing device.
The polyaniline sensor was connected in series with a resistor to the Arduino 5V and ground pins. A wire connected the circuit to the Arduino analog input, which measured the voltage drop across the resistor as a number from 0 to 1024. The voltage drop across the resistor decreased as the sponge was bent due to the increase in the polyaniline conductivity. When the analog reading dropped below a certain threshold, a digital pin was set to high, switching a transistor and lighting an LED. The increased conductivity causes a larger voltage drop across the sponge and a smaller voltage drop across the resistor. In this video, we see an example of a bad squat. Notice how my knees extend way past my toes. The polyaniline pressure sensor lights up red to tell me that I stretched too far and to adjust my form. Now we have an example of a good squat. Notice how my knees do not go past my toes. This is proper safe squatting technique, and the sensor does not light up to show me that my form is on point.
So dude, how are those squats going?
Hi Key, this device slaps. Can this work on other potential injuries like racquetball or tennis elbow soreness?
Yeah, you can use this sort of technology to non-invasively monitor how any physical therapy patient flexes their joints in order to effectually treat them.
Dude, that sounds really cool. Let's ask if Professor Huang plays and try it out on him.
Yeah,